A rod hinged at one end is released from horizontal position as shown in the figure. When it becomes vertical, its lower end separates without exerting any reaction on the breaking point. Then the maximum angle theta made by the hinge upper half, which is still hinged, will be equal to, with the vertical, will be equal to. Now first of all, let me draw the four positions over here. Let this be position P, okay, when the rod is horizontal. Let this be position Q when the rod arrives at this position, at the vertical position. Let there be another position which is equal to R, okay, when the rod separates and breaks down into two different parts, the upper half and the lower half. And let this be position S when the finally the rod temporarily arrives at rest, okay. So basically let us first write down the first process, that is from P to Q. So for process P to Q, I can say that the total energy at P will be equal to total energy at Q, assuming that there is no loss of energy due to friction. So total energy at P will be only equal to the potential energy, which will be equal to mgl. The height from this reference point will be over here equal to L, okay, and the total energy at Q will be equal to both potential plus the kinetic energy, potential plus kinetic energy at point Q, okay. So at point Q, I can say that the center of the mass will lie at this height at the length L, okay, at a height of L by 2 from the bottom, okay. The center of the mass will lie at a height of L by 2 from the bottom. So basically over here, the potential energy will be equal to mg L by 2 plus the kinetic energy over here will be equal to half I omega square. Since the rod is rotating about one of its end, it will be equal to, first of all, let me simplify this part, mgl by 2. The moment of inertia will be equal to ml square divided by 3 into omega square, okay. Now the total energy at point P will be equal to total energy at point Q. So I will directly write over here, this is equal to mgl. So basically it will be equal to mgl divided by 2 is equal to over here, it will be equal to ml square divided by 6 into omega square. So basically m and m will get cancelled out, L and L will get cancelled out, 2, this will become 3, okay. So omega square will be equal to 3g divided by L, or omega will be equal to root 3 gl, okay. This is the value of the angular velocity at position Q, okay. When the rod has still not broken down, it will be equal to 3g divided by L, omega square will be equal to 3g divided by L. What will happen after the rod breaks? After the rod breaks, that is at the position R, that is at the same position, after the rod breaks over here, the upper end of the rod will continue with the same velocity, or it will continue, or the initial velocity of the upper end of the rod, that is the AB section, will remain same, and the lower end of the rod will also remain same, regardless of what happens after breaking, okay. So over here the upper end remains L by 2 and the lower end also remains L by 2, the lower L by 2 will also continue with the same velocity. So now let us find out for the third position, that is the total energy at point R. Now we will calculate only for the for the upper end. For the lower end, I do not care what is the value, because we do not have to find out what happens to the lower end. We will only concentrate on the upper end, which will continue the same circular motion as it did initially. So the total energy now over here, the rod, since it has broken down, the mass over here will be equal to m by 2 and the length over here will be equal to L by 2. So now the total energy over here, the center of mass has been shifted at half of this length, that is at a height of L by 4, okay, that is at a height of L by 4. So now the potential energy over here, again the total energy will be equal to potential plus kinetic energy. It will be equal to m by 2, the mass has been halved, g L by 2 plus half I omega square, okay, which can be written as mg L divided by 4 plus over here mgl divided by 4 plus half. The moment of inertia will be equal to m by 2 into L by 2 the whole square into 1 by 3 into omega square, okay. This will be the moment of inertia. So basically this will be equal to mgl divided by 4 plus this will be equal to ml square divided by 16 into 3 into omega square. Omega square is equal to 3g divided by L. So basically 3 and 3 will get cancelled out, 1L will get cancelled out over here. It will be equal to mgl divided by 4, okay, mgl divided by 4 plus over here it will be equal to mgl divided by 16, okay, mgl divided by 16 over here, okay. So basically over here, or the length of the rod has been shifted to L by 4, okay, not L by 2, it has been shifted by L by 4. So this will be equal to 4 into 2, 4 into 2, so this will be equal to mgl divided by 8, okay, mgl divided by 8. So basically this will give me the answer 3 mgl divided by 16. This is the total energy at point R, okay. Now let us find out the total energy at point S. At point S, the center of the mass over here, if I zoom in over here, the center of the mass will be at this height, at a height of L by 4, okay, at a height of L by 4 over here. So its height from the bottom will be equal to mg, the entire length, this entire length over here will be equal to, over here this will be equal to the center of the mass, the original center of the mass will be at a height of L by 4. So this will be at a height of L by 4, and the component, since this angle over here is equal to theta, this component over here will be equal to L by 4 cos theta. So the height from the bottom, so if I zoom in this diagram, the diagram will look somewhat like this, okay. This is the original center of the mass which was at a height of L by 4, and now the rod has bent, okay. Now this is L by 4 and this angle over here is equal to theta. So this height over here will be equal to L by 4 cos theta. So the height that has raised, the height the center of mass has raised will be equal to L by 4 minus L by 4 cos theta, okay. They have asked what is the maximum height raised. At the maximum height raised, it means that momentarily at the position R, the body will come, will arrive at rest, okay, or will be at rest, and then it will again rotate in the clockwise direction, okay. So the body will only have potential energy. So the total energy at point S will be only equal to the potential energy, which is equal to m by 2 g into L by 4 minus L by 4 cos theta. Over here we will equate the total energies over here. It will be equal to 3 by 16 mgl is equal to mg by 2. I will take L by 4 common. It will be equal to 1 minus cos theta, okay. Over here mgl will get cancelled out, 4 2s are, so this will be equal to 2. So basically 1 minus cos theta is equal to 3 by 2, or I can say that cos theta over here will be equal to half, or theta over here will be equal to 60 degree. So the maximum angle made with the vertical will be equal to 60 degree, which is option number C.